We will now continue to part 2 of this presentation. Hard fescue is an excellent grass when there will not be a high amount of traffic and/or wear. Most home lawns would fall into this situation. The species does not grow very quickly. Therefore, mowing is often reduced. While other grasses are struggling during periods of heat and drought stress, hard fescue is often still bright green, providing a usable turf. Chewing's fescue is very similar to hard fescue. Although it is a bunch-type grass, it forms a very dense turf through aggressive tiller formation. This species seems to adapt very well to shaded conditions. One negative is that it may suffer under long periods of ice cover. Sheep fescue is often a bit more bluish in color than the other fine fescues and is primarily used for no-mow areas such as hillsides. The most commonly used fine fescue, strong creeping red fescue, is often mixed with Kentucky bluegrass in areas that are partially affected by shade. In the sunnier areas of the turf area, the Kentucky bluegrass will thrive, while in the shaded areas, the creeping red fescue will thrive. This fescue spreads quite easily due to its rhizomatous growth habit. The species does not perform well under dry and hot conditions and is susceptible to several diseases. Here is the dense green turf characteristic of hard fescue. The other fine fescues have a similar appearance. When it was first introduced into this country, tall fescue was thought of primarily as a forage grass for livestock. It was first used as a turf grass in the 1940s and 1950s. The first variety used for turf was Kentucky 31. This variety was quite coarse and light green in color, so it did not produce an attractive turf. However, it did possess the ability to produce roots deep into the soil profile. This characteristic is what makes tall fescue drought avoidant. This species can perform better than most cool season species during drought, not because it doesn't need as much water, but because it can reach deeper into the soil. The first improved variety of tall fescue was released in the early 1980s. Current varieties of the species are used in home lawns, athletic fields, golf courses, and parks. Turfgrass managers usually refer to these improved tall fescues as turf-type tall fescues. The drought avoidance of tall fescue makes it a very desirable turfgrass for a sustainable lawn. Tall fescue lawns can be watered less frequently than lawns that contain other cool season species. The species is also very tolerant of wear, and there are very few diseases that are a major problem in the Midwest. Traditionally, tall fescue has been perceived to have a lack of winter hardiness. Recent research indicates that the primary reason for tall fescue death during harsh winters is prolonged periods of ice cover. In areas that do not experience ice cover, winter hardiness does not seem to be a problem. Some of the older varieties of tall fescue have fairly wide leaves that leads to a coarse leaf texture. Newer varieties have much finer leaves and are more acceptable for use in areas where aesthetics are important. The positives listed on this slide fit really well into an ideal roadside turf, and the leaf texture and perceptions problems are not an issue for the most part on a roadside management situation. What is a problem is tall fescue's inability to do well under ice cover. This isn't so much a problem on a sloped roadside, but a major problem along most roadsides in residential areas where there often can be a slight dip in the soil profile between the sidewalk and the curb. This slightly concave shape to the landscape profile can collect extra water, resulting in ice buildup during the winter. This table shows the results of a mixture study that was conducted by researchers at the University of Minnesota. Take a moment to review this chart. Several roadside mixtures were tested, with each mixture being some combination of various species. The details of this table are unimportant for this module, but what is important here is the coefficient column. What this table is showing is the likelihood of success of a mixture based on the inclusion of a certain species. In this case, positive coefficient values indicate a positive effect, while negative coefficient values suggest that the species had a negative effect on overall mixture performance when included. Tall fescue had a negative and significant as noted by the low p-value in the far right column effect when included. This was not surprising, as this site had a slightly concave profile and there were long durations of ice cover during the winter. Alkali grass, as the name implies, is known for its ability to survive in soils that are high in salt as well as high pH soils. This is a very common inclusion in roadside mixtures, but it has poor turf performance. In our research, we have found that these alkali grasses, which include a couple of different related species, do well for one winter if properly established. The problem with this group of species is that it doesn't do well under most other stresses found on a roadside, so it will likely decline to a point of disappearing rather quickly, so it functions as an annual. Newer cultivars could perform better. This data is from the same trial we covered earlier in this module. We'll give you a moment to review this graph. This data is from the Min Road Research Facility along Interstate 94 near Albertville, Minnesota. Once again, you are looking at the top ring varieties. The alkali grasses in the trial were the best, and this is quite impressive given the high salt load expected at a very heavy traffic site such as this. The picture on the right is of alkali grass when grown in a turf research study with no inputs after establishment in Minnesota. Once it was seeded and started growing, the only input added, in addition to natural rainfall, was mowing. It didn't do well at all compared to the tall fescue. The variety pictured here, false, has often been recommended for roadsides. However, because the grass does not persist well in a mowed situation, researchers are beginning to evaluate newer, improved cultivars of alkali grass for roadside use. This table shows the results of the same study. Take a moment to review this chart. Every instance of a species performing acceptably, above 5 for a quality rating in this case, is highlighted in yellow. Note that alkali grass is the worst performer at most locations and didn't perform at an acceptable level at any testing site. The next several slides will compare 4 common cool season turf grasses for various performance measures. If aesthetics were the only concern for a roadside turf, then Kentucky bluegrass would be the best choice. However, as will be demonstrated in the forthcoming slides, this species lacks the stress tolerances needed for the harsh roadside environment. Rapid establishment of seed is important for roadside seedings. For this trait, perennial ryegrass is the best choice. Some roadsides experience tremendous amounts of compaction. For these sites, tall fescue might be a good option because it tolerates traffic. For the most part, roadside turf does not receive irrigation beyond natural rainfall. Therefore, drought tolerance is a very important trait. Tall fescue and fine fescue can both do well during short periods of drought during the growing season. Kentucky bluegrass, however, is the best of these grasses at surviving long-term droughts. It has an excellent summer dormancy mechanism. The species will turn brown and go dormant during a drought, and then has the ability to quickly regrow once rain returns. In cooler climates, tall fescue and fine fescue might be expected to have the fewest disease problems. Winter hardiness is very complex and has several components, including tolerance to long periods of ice cover, ability to survive very low temperatures, resistance to snow mold disease, and tolerance of desiccation. Desiccation can be thought of as a winter drought, typically a problem during winters with very little snow cover. The grasses typically recommended for roadsides in the northern U.S. do quite well for winter hardiness. Perennial ryegrass has poor tolerance to most winter stresses and should be avoided in cold climates for that reason, although it can be used in smaller proportions to reduce erosion early in stand establishment. Ice cover is a problem on many urban roadside sites, so it is instructive to think about tolerance to this stress individually. Kentucky bluegrass can survive this trait quite well, as can most of the fine fescue species. Heat stress is also a major concern on roadsides. Tall fescue is the most tolerant of these 4 grasses to heat stress. One of the primary problems that fine fescues can face on roadsides is the higher temperatures found in the roadside environment. When stresses are experienced by these grasses, the recuperative ability of each species is important. This is another area where fine fescues do not do well. Balancing the risk of damage from stress with a grass's ability to recover from that stress is a challenge. In 2010, the Minnesota Department of Transportation partnered with the Minnesota Crop Improvement Association and the Minnesota Turf Association, which consists of sod farmers in Minnesota, to develop a salt-tolerant sod certification program. The idea behind this program is that inspectors from the Minnesota Crop Improvement Association would track and inspect sod that was grown for use on roadsides so that installers could be assured that the product they were installing was in line with current recommendations. This program uses unbiased data and has resulted in a number of changes to the seed mixtures recommended for roadsides in Minnesota. We'll take a slight pause to review the information on this slide. The original goal of the University of Minnesota project was to improve the original salt-resistant seed mix that was first seen in the 1994 MnDOT spec book. There are very high proportions of both alkali grass and Kentucky bluegrass, both species which are not ideal for this use. Because Kentucky bluegrass seed is quite small compared to these other species, the actual number of seeds per unit area is much higher than the percent by mass, meaning that this recommended mixture is almost all Kentucky bluegrass. Take a moment to review this chart. The MNST-12 mixture was designed in 2012 based on research at the University of Minnesota. The primary change from the more traditional mixture is that the proportion of Kentucky bluegrass has been greatly reduced, while the proportion of fine fescues has jumped significantly. The amount of Kentucky bluegrass seeds is still quite high in this mixture, considering that the seeds of that species are about 1/5 the size of fine fescue seeds. This is done primarily to ensure that sod producers can produce a harvestable product as Kentucky bluegrass, which, due to its rhizomatous growth habit, is able to better form a sod that can be easily cut and transported. Although this mixture was designed for sod applications, the mixture should also be used for roadside seedings in cold climates where salt applications during winter affect roadside vegetation. As new data is generated, modifications will be made to this mixture. Selecting the best species for a roadside installation is one important step, but it is not enough to ensure successful roadside turf establishment. Other important factors include the time of year, watering, soil preparation, temperature, and many other factors. You will learn about each of these in coming modules. Thank you for viewing Turfgrass Species for Roadsides. In the next module, we will discuss the process of soil preparation.